All right, how's it going, students? Thank you for watching this video. Um, since you guys are watching this video, there's a great chance you guys will get a very good grade on the test. All right, let's jump into question number 2. We have x squared multiplied by x to the 4th power. All right, so we have the same base x. Since we have the same base, our exponent rules tells us we go ahead and add those exponents. 2 plus 4, that gives us x to the 6th power. All right, question number 3, we have x to the 13th divided by x to the 5th. Remember our rule when we have the same base, but we're dividing, we subtract the exponents. 13 minus 5, that gives us an answer of x to the 8th power. Remember, we always do numerator minus denominator, and our answer that we get, we can sort of think of it as going in our numerator. All right, 3 to the negative 2nd power. Remember, students, whenever we have a negative exponent, our goal is to make it a positive exponent. How do we do that? We write a fraction and we move it down to the denominator, right? So doing so makes it a positive 2. And then we still have the 1 on the top. All right, but now we have a number squared. We need to go ahead and simplify that. Remember, exponent, that means what we're multiplying. We're multiplying 3 times 3, 2 times, right? 3 times 3, that gives us 1 over 9. Final answer. All right, question number 5. We have 5 multiplied by x to the 0. So if you guys see this, don't make the mistake of just assuming it's 1, because our rule says anything multiplied or anything raised to the power of 0 is equal to 1. You're absolutely correct. But remember, there's technically a multiplication in between this. So this is 5 multiplied by x to the 0 power. So x to the 0 power, that's 1, but it's 5 multiplied by 1, which gives us an answer of 5. All right, question number 6. So we have x squared multiplied by y, all of that raised to the 4th power. So remember, using our rule, if we have something raised to an exponent and that's raised to another exponent, we have to go ahead and multiply that. So we have to go ahead and think of this as being distributed to the 2 and distributed to the 4. All right, so multiplying 2 times 4, that gives us x to the 8th power. And then 4, you can think of it being distributed to the 1st power. So 4 times 1, that gives you 4. So y to the 4th power, just like that. All right, so question number 7. Question number 7 is a little tricky, but let's go ahead and I'm going to rewrite this a different way. So my numerator, I'm going to rewrite it as -1 multiplied by n cubed divided by 10. And all of that being raised to the 4th power. All right, so why did I rewrite it like that? Well, a lot of students are getting confused with this negative, or maybe they're trying to apply that negative exponent rule. Remember, that negative exponent rule only applies to, well, negative exponents. This is just a number. We can think of it as -1. So we go ahead and distribute that 4 to each of these, just as we did with problem number 6. And we have to distribute that 4 to the 10 as well. So doing that, we get, well, -1 to the 4th power multiplied by n cubed raised to the 4th power, all divided by 10 to the 4th power. All right, so simplifying that, -1 to the 4th power. Don't mistake this for multiplication. This is -1 times -1 times -1 times -1, right? Multiplying that out, we just get a positive 1, so we don't need to think about that. Then n to the 3rd raised to the 4th power. We can think of the power rule. So we have to go ahead and multiply 3 times 4. That gives us n to the 12th power. And then 10 to the 4th. Once again, that's not multiplication. It's not 40. 10 to the 4th is going to be 10 multiplied by 10 multiplied by 10 multiplied by 10. All right, doing so, you can just think of 10,000, right? 10 multiplied by 10, there'll be 4 zeros after you multiply it out 4 times. So yeah, final answer, n to the 12th divided by 10,000. All right, so question number 8, we have v to the negative third divided by z to the negative fourth. So we see we have negative exponents. Let's take care of it one at a time. We have a negative exponent in our numerator. To make that a positive 3, we need to move it down to the denominator. That becomes v to the positive third power. And since this is in our denominator, to make it a positive z to the fourth, we have to raise it to the numerator, z to the fourth power. All right, question number 9, we have r to the fourth divided by p squared, all of that raised to the fifth power. So remember, once again, we can apply the power rule. We have to sort of distribute this 5 in there, and we have to distribute it to our denominator, right? Both our numerator and denominator. So r to the 4 raised to the fifth power, we have to multiply. So 4 times 5 gives us r to the 20th. And then p raised to the 2 times 5. 2 times 5 would be, as you guys know, 10. So p raised to the 10th power. Final answer. All right, question number 10. All right, so first, as you guys know, we start by thinking of our numbers first. So 8 divided by 2, that would give us 4. All right, so let's create a fraction. 8 divided by 2, that gives us 4, as I said. We have to write that in the numerator. Write it in the denominator, remember that's sort of like 1 divided by 4. All right, so next we think of our base of p to the 6th power divided by p to the 3rd power. Well, 6 minus 3, that gives us p to the 3rd power. And then r to the 3rd power divided by r to the 8th power. Well, once again, subtracting those exponents, be careful of our signs. We have r to the negative 5th power. All right, and then all of that is, I guess nothing's in the denominator right now. So yeah, we can rewrite it as just a 1. But anyways, we still have a negative exponent. So we need to go ahead and try to simplify that. So our r to the negative 5th power, that's in our numerator. So we switch it down to our denominator because we are trying to make it a positive. Doing so makes it a positive. All right, and then in our numerator, we have 4 p to the 3rd power. That still stays in our numerator, right? That is your final answer. All right, question number 11. So we are multiplying all of these together. So first, remember, we think of our numbers first because it's just common convention to write our numbers in front of our letters. So our numbers first, that would just be negative 4 times 6. That gives us negative 24. And then we look at our x's. Well, we have x squared and x to the 10th power. All right, so when we multiply, remember, we add those exponents. 2 times 10, that gives us 12. And then we think of our z base, z to the 4th multiplied by z to the 3rd. That gives us z to the 7th power. All right, final answer. All right, question number 12. I had to get a new sheet of paper because this one is a little tricky, but we can just take it one step at a time. All right, so as we have all of these are exponents, and then it's raised to another exponent. So we have to sort of think of distributing this negative 2 to each of these factors. Right there, and right there. And remember, we also have to do it to our denominators, right? Or factors in our denominators. We have to distribute it to that 3. And then we have to distribute it to that 8. So let's go ahead and write that out. We have 8 raised to the negative 2nd power multiplied by x to the 6th power raised to the negative 2nd power, and then y to the 4th power, once again raised to the negative 2nd power. And then all of that divided by, well, that'd be 3 raised to the negative 2nd power, and then x to the 8th power raised to the negative 2nd power. All right, so we have a bunch of negative exponents. So remember, how do we make those negative exponents positive? First, well, we can draw our line. So we have our numerator and denominator. All of these are negative. So since this is a negative, it's going to move down, negative, down. This is going to move down. And then this is going to move up. And then this is going to move up, right? So let's just go ahead and switch that fraction around. Everything in our numerator is going to be in our denominator with a positive 2 exponent, though. So x to the 6th raised to the positive 2, and then y to the 4th raised to the positive 2. And then 3 raised to the positive 2, and then x to the 8th, that is going to be raised to the positive 2 as well, too. All right, so let's go ahead and start to simplify this. 3 squared, that gives us a 9, right? 3 squared, the same thing is 3 times 3. All right, x to the 8th power raised to the 2nd power. Using our rule, we know we have to multiply those exponents. That becomes x to the 16th power, all divided by 8 squared. What does that give us? That gives us 64. 8 times 8. X to the 6th power raised to the 2nd power. That's going to be x to the 12th power, multiplying those. X to the 12th. And then on the bottom, we have y to the 4 times 2. That gives us 8. Y to the 8th power. All right, last step, we need to go ahead and simplify this. 9 divided by 64. We can't simplify that. Why can't we simplify that? Well, the only factor of 9 would be 3. 3 and 9, I guess you can think of it. But 9 doesn't go into 64 evenly, and 3 doesn't go into 64 evenly. So we would still write it 9 over 64. Those are still the same. But now we can start to simplify our x. X divided by x to the 16th power, sorry. X to the 16th power divided by x to the 12th power. You guys know that we subtract those, and when we do so, that stays in our numerator, x to the 4th power, right? 16 minus 12 gives us 4. And then our y to the 8th, that still stays in our denominator. Since, well, there's no negative exponents, we don't have another y in our numerator, so we just rewrite it. All right, so a lot more involved with this one. As I said, it was a little bit more trickier, but we worked through it step by step. This is our final answer. All right, question number 13. Sort of the same concept, right? We have all of this being raised to the 2nd power, so we have to go ahead and distribute that. So on the test, a very common mistake that you'll forget to distribute that 2 to the 3. All right, so don't forget that. Distribute this 2 to the 5th power, and we think of distributing that 2 to the 1st power. All right, and then you can think of this 3 being distributed as well to that r and to that c. All right, so let's try to write that out. 3 raised to the 2nd power, and then r raised to the 5th power raised to the 2nd power. That's going to be r to the 10th, right? Because we just multiply it. And then c raised to the 2nd power. All right, so that's going to be multiplied by, well, distributing that 3 to the r, that's going to be r to the 3rd. And then c to the 3rd, same thing. All right, and lastly, let's use our rules to go ahead and simplify this. Well, 3 squared, that's just 3 times 3, so that's a 9. And then we have our r bases, r to the 10th multiplied by r to the 3rd power. Multiplying that out, that's going to be r to the 13th, right? Because we're adding them. Adding our exponents, 10 plus 3, 13. And then we add our c exponents. That would be c raised to the what power? Well, 2 plus 3, that gives us 5. All right, final answer. All right, question number 14. So it says to evaluate when a is equal to 3, b is equal to -2. All right, so let's go ahead and use that information. So we literally plug in, what did they say? 3 for a, and then -2 for b. All right, and then it's just a matter of simplifying this using order of operations. So remember, students, order of operations, we have grouping and then exponents and then multiplication and division. So we have to do this exponent before we multiply. So -2 multiplied by -2, that gives us +4, right? So after that, it would just become a multiplication problem. -3 multiplied by 3, that gives us -9. -9 multiplied by 4, that gives us an answer of -36. Final answer. All right, question number 15. So when I was helping some students, a lot of them plugged in for A, and they plugged in a number for B first, and then they solved it. I mean, that's not wrong, but it's a lot easier to just go ahead and simplify this using our rules that we know. And so let's go ahead and do that. We have 3 minus a -2, right? Since we're dividing, we need to subtract those exponents. 3 minus a -2, be careful, that's going to be a +5, right? So a to the 5th power. And then b squared divided by b to the 5th power, that's going to be 2 minus 5. That gives us an exponent of -3. All right, so simplifying that, remember we still have a negative exponent. How do we simplify that? Well, we have to first bring our -3 down to our denominator. And this a to the 5th power still stays in our numerator. So a to the 5th power. And then now we can go ahead and plug in our numbers. So we have a is equal to, what did we say, 3? Yeah, so 3 to the 5th power. All divided by, well, b to the 3rd power. Yeah, so make sure you guys write that -2 in parentheses to the 3rd power. All right, so 3 to the 5th power, I believe that's 243. And divided by -2 times -2 times -2, that's going to be a -8. All right, so this one looks like it could simplify, but nope, that's your final answer. 243 divided by -8. All right, number 16. So I started with my formula. It's always good to rewrite our formula so that we can keep ourselves organized. All right, so P, that's going to be our principal or our initial amount. It says we initially deposited 10,000, so let's go ahead and write that. 10,000 multiplied by 1 plus our R is going to be our rate. Well, it's 8%, but remember we need to write it as a decimal. Writing that as a decimal, it's 0.08 divided by n. So n, remember, that's the number of times per year. So always look for that word compounded, and whatever they say after that, well, that's how many you think of. You think of how many of those are in a year. So it says compounded weekly. So as you guys know, 52 weeks in a year. So we go ahead and divide that by 52. And then we go ahead and we raise it to the exponent of n, which we just said was 52, multiplied by t. So our t is in years. They say it's 20 years. All right, so putting that into our calculator. Once again, students, let me just go ahead and show you guys how to enter this into your calculator. So 10,000, then we have to put it in parentheses, 1 plus 0.08. And then whenever we have a fraction, that's just the same thing as division. So we go ahead and divide that by 52. All right, make sure that parentheses gets closed. And then we go ahead and raise it. All right, so whenever you do that exponent, you can multiply this out first. Actually, I would suggest you guys multiply this out first. But if you want to just enter it into your calculator, the reason why I said to multiply it out first is so that you don't make this mistake that I'm about to show you. 52 times 20. Some of you might forget to put the parentheses around this, and that'll cause your calculator to give you a wrong answer. So you can either do it like this, as I show you, or as I said, I would prefer you guys to just go ahead and multiply that out. 52 times 20 first. Oops, I deleted it too much. Divided by 52. All right, and that's going to be raised to the 1040. Yeah, 1040 power. 52 times 20. All right, so that gives us an answer of, let's go ahead and write this out. In your guys' Go Formative, I need you guys to write the dollar sign and then all the commas that you need. So this one, you'll only need one comma. So 49,469. And then I need you to round to the nearest hundredths. So 46 cents. There you go, final answer. All right, question number 17. We're using the same formula, so I went ahead and wrote it down. All right, our principal, or our starting amount, we start with 20,000. All right, all of that is going to be multiplied by 1 plus, well, our rate. Our rate is 5.2%. So moving that decimal over to the left, we get 0.052 divided by, well, we look for the word compound, and then whatever follows after that, we want to ask ourselves, how many of those are in a year? So it says compounded daily. So as you guys know, there's 365 days within a year. Right, and then, well, our n, same thing, 365 multiplied out by, let's see, what did they say? 10 years. Our time is 10 years. All right, so if you did that correctly, I would practice entering that into your calculator. On Go Formative, your final answer with the dollar sign and commas, $33,639.31. All right, question number 18. Same formula. Or no, different formula. Sorry, I apologize. Let me go ahead and rewrite this. All right, so I'm glad I caught myself. I thought it was going to be a compound interest formula. The reason why I knew it wasn't going to be it, well, because the problem doesn't say compounded, right? And then, well, it says it depreciates, so we know it's going to be an exponential decay formula. So, which is exactly what I have here. A multiplied by 1 minus r to the t power. So our bolt starts off worth $4,000 or 40,000. All right, and then we subtract our rate as a decimal. It says 15%. So writing that as a decimal, 0.15. All of that raised to the t power. So how much would it be worth after 3 years? All right, so entering that into Go Formative with our dollar sign, you should have it as 24,565. All right, no decimals, comes out to an even number. All right, question number 19. They want us to graph y is equal to 2 multiplied by 3 raised to the x power. So for this one, I only need 3 things from your guys' graph. I want you guys to graph the y-intercept. I need y-intercept. I need the general shape. So the general shape of a graph, if it's increasing, it's going to look something like this. And then if it's decreasing, well, it's going to look something like this. It decreases really quickly, then it slowly fades off like that. All right, and then the third thing, I need your guys' graph to approach the y-asymptote. So, sorry, I didn't mean y-asymptote. I meant asymptote. Asymptote. But that's usually as a default. That's going to be y is equal to 0. All right, so for this problem, how do we find our y-intercept? We have to go ahead and plug in 0. Remember, 0, we plug in 0 for x, and we solve for y. So let's go ahead and do that. We have f of 0, remember our function notation, that literally means to plug in 0 for x, 2 multiplied by 3 raised to the 0 power. So some students might think to multiply this 2 times 3 first. Remember, order of operations tells us we need to do exponents first. 3 raised to the 0 power, that's going to be 1. So that's literally 2 times 1. That gives us an answer of 2. All right, so our input is 0. Our output is 2. That's our y-intercept. All right, our general shape, is this going to be increasing or decreasing? Well, think of it this way. Our base is 3. So we can think of it as keep on multiplying that, right? Because that's what our exponent means. We're just going to raise it, whatever, to that x power. If we keep on multiplying it, 3 times 3 times 3 times 3, of course, that's going to be increasing. There's no way that gets less and less and less. So yeah, our general shape of our graph is going to look something like this. And then our asymptote. As a default, it's y is equal to 0. Remember, it only changes if you have like something added or subtracted from it. So yeah, our asymptote is going to approach y is equal to 0. So putting all three of those things together, let's go ahead and draw our x and y axes. All right, so it needs to increase. It needs to pass through the point 0, 2. Right, that's 1, 2. All right, so that's the only point you need in our graph. And then we just want the general shape of it increasing, and it needs to sort of approach our y is equal to 0 line. So let's go ahead and draw that. So our asymptote y is equal to 0, so we need to start off by y is equal to 0. And then we're going to slowly start to increase through our y-intercept, because it definitely has to pass that point. And then our general shape of our graph, since it's an exponential function, it needs to increase really, really steeply, like so. All right, yeah, and that's all you need. I just want the general shape of our graph. Doesn't have to be exact. The only exact point I need is your y-intercept. All right, so question number 20. Is this linear or exponential? Remember, a linear function would look something, well, it would be line. Of course, this is an exponential function. It's an exponential function, remember from our notes, if the variable x is in our exponent. That's how we know it's an exponential function. All right, question 21. What is the y-intercept? Well, we answered this question by graphing. So y-intercept 0, 2. All right, is this function increasing or decreasing? Question number 22. Well, we also answered that question, right? Increasing. Question number 23, our domain. All right, let me go ahead and write this down. Remember, our domain, it's always going to be negative infinity to infinity. It doesn't matter what exponential function they give us. If you see exponential function, it's always going to be negative infinity to infinity. Once again, if you guys want to know the reason why, well, a domain just means all the possible numbers you can input into your function. So there's no math law stopping us from literally replacing x with any number we want. All right, number 24, what is the range? Well, remember, we think of the range as from the bottom of our graph to the top of our graph. So let me go ahead and rewrite that. Let's see, 24? Yeah, 24. Our range. So it needs to be the bottom of our graph, and then our second number is going to be the top of our graph. So the bottom of our graph, well, that definitely has a relationship with the asymptote. So even though it doesn't reach 0, we can think of it as getting pretty close to 0. So our bottom is going to be 0. And then the top of our graph is going to be, well, this line, it doesn't stop increasing, right? So that's going to keep on going up and up and up. So 0 to infinity. All right, 25. What is the asymptote? Well, we already answered that. That's y is equal to 0. That letter y, definitely important. You can't just put 0. That's something else. I need you to put y is equal to 0. Or if you're thinking about x is equal to 0, remember x is equal to 0 is a vertical line. We want a horizontal line, so we have to put y is equal to 0. All right, number 26, what is the function worth in 2 years? I don't really like that question because they don't really give you any information saying that it's, I don't know, any background information, but basically they just want you to plug in 2 for x and solve there. So let's go ahead and do that. Plugging in 2 for x, we get y is equal to, what was it? 2 multiplied by 3 raised to the second power. All right, so once again, we have to do our exponents first. That'd be 2 multiplied by 9. That gives us an answer of 18. All right, 27, same thing, except we're replacing our x with 5. 2 times 3 raised to the 5th power. All right, so 3 raised to the 5th power, that's going to be 243. Multiplying that by 2, we're just bringing our 2 down. That gives a final answer of 486. All right, problem 28 and the next couple of problems. They ask us to determine which of these functions is growth and which is decay. Remember, you just need to look at the functions below. All right, I just wanted to rewrite all of these, or write it out so I can just easily point to what I want you guys to look at with each of these functions. All right, so we want to know whether it's growth or decay. So when you're looking at these functions, the only number you guys care about is whatever is raised to our variable x, or our base, right? So we only care about our bases. Since our base is 5, you can think of it like this: 5 multiplied by 5 multiplied by 5, and so forth. If we keep on multiplying 5, it's of course going to keep growing. So this one would be growth. All right, 29. Once again, looking at just our base. Our base is 3. 3 times 3 times 3 times 3 times 3, and so forth. That's, of course, going to keep growing. That should be growth. All right, so looking at our base, we don't care that this is a 2. We only care about our fraction, 5 divided by 7. All right, so if we keep multiplying a fraction, multiply a fraction, multiply a fraction, multiply a fraction, we're going to get less and less and less. So that's going to be decay. And then 31, well, that one's probably the easiest out of all these. We just look at our 5. We know, as I said before, 5 times 5 times 5 times 5, that's going to grow. So growth. All right, number 32. They want us to graph this function 1/2 raised to the x power plus 1. So remember, we need our y-intercept. Y-intercept. So how do we find that? We go ahead and plug in 0 for x. Y is equal to 1/2 raised to the 0 power plus 1. 1/2 raised to the 0 power, that's going to be 1. Bring down the plus 1. That's going to be 2. All right, so our y-intercept, we plugged in 0. Our answer was 2. So 0, 2. All right, we also want to know if it's increasing or decreasing. As I said before, this is a fraction. Because that fraction is raised to our variable, we know that it's going to be decreasing. So decreasing. All right, 2 out of 3. And the last one, we want to know where our asymptote is. So remember before, as I said, our default is always going to be at y is equal to 0, or our line is going to be y is equal to 0. But what happens when we have something added to it? Well, that moves our line up by, well, how much ever we add to it. So since we're adding 1, it moves our line up by 1. So our asymptote, let me go ahead and write that out. Our asymptote is at y is equal to 1. All right, so once we have all 3 of those, we can go ahead and try to start graphing our graph. All right, so let's go ahead and draw a dashed line to represent our asymptote. That's y is equal to 1. And then we use the fact that we know we want our graph to pass through 0, 2. That's 1, that's 2. So we need it to pass through that point. And then we also need it to decrease, right? Remember, if it decreases, it starts from left to right. So we start up high and then we go down low as we get further. All right, so we know that our graph is starting up here, needs to decrease sharply. And then once we pass our point that we need to go through, we're going to start to approach our asymptote very, very slowly. And then, yeah, I mean, it's hard to draw something where it looks like it doesn't touch, but if you draw anything that resembles this on your test, I'll give you full credit, as long as you have these features on your graph. All right, 33, it says a critical point on the graph is -2 comma something. This is just a fancy way of saying, well, we want to figure out what our function is of -2. So we simply just have to replace x with -2. All right, so 1/2 raised to the -2 power plus 1. All right, and then we go ahead and use our exponent rules. All right, we have a negative exponent. All right, actually, let's think of it. It's easier to think of it this way. We distribute that to there. We distribute that to there. So we get 1 to the -2 power over 2 to the -2 power. And then we still have a plus 1. So we'll go ahead and add that. All right, and then now we have negative exponents. So drawing our fraction, both of these are negative exponents. So you can just go ahead and think of flipping it. That would be 2 squared in our numerator, and then 1 squared in our denominator. Then we still have the plus 1. All right, so finally that gives us, well, 2 squared is just going to be 4. 1 squared, that's just 1 times 1. So 4 divided by 1, that's still going to be 4, and then plus 1. So final answer should be 5. Yep, -2 comma 5. All right, and then 34, our asymptote. Well, we already said that. That's going to be y is equal to 1. Asymptote, y is equal to 1. And then what's the range? Well, remember, our asymptote and range goes hand in hand, right? Since our bottom of our graph is at 1, literally our range is from 1 to infinity. Let me go ahead and write that. 35, range 1 to infinity, as so. No spaces. Make sure there's no spaces. And yeah, that's it. So hopefully you guys like this video. Yeah, if you guys have any questions about it, feel free to email me, and study hard. Thanks, guys.